How do we do it? Okay, take a look at your graph. What do you see on top? The normal graph, x, y coordinate system, the Cartesian coordinate system. On the bottom you see what? Polar. Well, do you know that for the last couple days you and I have been converting from rectangular to polar, polar to rectangular, right? Well, we're graphing. We're going to graph polar equations. And here's how you do it. You first graph it on the rectangular coordinate system, here. Then you convert these points, all the points you convert them to polar, and you put them down here. So you look at this, and you convert the points to this. And it forms one of those circles, okay? All right, but you probably forgot how to graph on the XY coordinate system. Maybe you did, maybe you didn't. Let's look. Okay, this is it. I only want to look at one function. It's the sine function, because cosine is so much the same. Okay, so let's just look at sine. There are things that can happen to your sine function. All three of these things can happen. Do you remember the period for sine? Sine repeats itself after how many radians? 2 pi. Aaron said it. 2 pi. So every 2 pi, the sine curve just makes, it's done. It will repeat every 2 pi. Okay, what changes the period? Look up here.
B.
Yeah, it's B. B changes the period. How? You just divide by B. This is the period. Every time. Normally that's 1, and if that's 1, the answer is 2 pi. Okay. What does this do? The number in front of sine. It's the amplitude. It stretches it this high or this low. So really, this could be your maximum at 3, your minimum at -3. Okay. What does this do? Plus C. Yeah, the whole wave just goes up, forward, or down, forward, whatever. Okay? I've got 4 of these on here. Let's do them. And we can do them pretty quick, I think. All right, here we go. All right, here we go. Sine of theta. This is the hardest part. If I let sine equals 0 degrees, I'm sorry, if I let theta equals 0, where does sine start? Where does sine start, guys? If I put 0 in, what do I get?
0.
I do get 0, but do you know why I get 0? Do you guys remember doing this? Remember that unit circle at 0 degrees? X, this point is 1, 0. The radius is how far? 1. What is sine? Sine is really just what? Y over R. What's your Y? 0. What's your radius? 1. What's the answer? 0. Look at that. That's why it's 0. You put 0 in, you get 0. Now I'm never going to do that again. Just tell me the answer. Ready? Let's get, first we got to know the period. The period is always broken into 4 equal parts. What is the period out of this one?
2 pi.
Yeah, the period is 2 pi because it's the b value is 1. So 2 pi. So this means that's pi, and this means this one is pi over 2 and 3 pi over 2. Good? Okay, where do we go first from here? Max. What's the maximum? Yeah, it's the number right here. It's the amplitude. It's 1 and -1. So you go to your max, you go to your 0, you go to your min, you go to your 0, and this is the curve. And the curve, watch this. At the very top, it's very rounded. It's very rounded. And from 0 up, it goes fast, and about right here, it goes fast down. So it's rounded on the top. So again, it's going down fast, and it's rounded on the bottom. And then it climbs and picks up speed again. Okay, there it is. Sine of theta is on the board. Are you okay? Slide over. What's this one going? Sine of 2 theta.
The period is just going to be pi.
The period is going to be pi, let's see, is she right? Take 2 pi, the period, divide by what? 2, and get what? Pi. She's right. 4 equal parts makes up the whole wave. This is pi now. But now the intervals change, right? Divide by 4, and you get what? Halfways would be pi over 2. Halfways between there, 0 and there? Pi over 4. This one? 3/4 pi. Good? Does the curve change? No, the curve's the same. Starts at 0, 0, hits its max, hits its min. What's the max? 1. What's the min? -1. There it is. It looks identical except the period ends at pi. This one ended at 2 pi. So that was it. Okay, what's your thoughts so far? Pretty easy? Okay, what's this one do? 3 sine of theta. Okay. Yeah, it's nothing big. It just goes up 3 and down 3. Okay, 1, 2, 3. Starts at 0. Okay, whoa. What's the period?
2 pi.
Yeah, because this is 1. So you basically do 2 pi divided by 1. Well, that's 2 pi. So this is pi. Up to 3, down to here. Max, 0, min, 0. Keep going. Keep going. All right, we got one left. If you look, this is 3 sine of theta, and this one is 3 sine of theta. So what do I do? Same thing, but move the whole curve up 2. So where would the max be now? 5. The max is 5. Where's the minimum? -1. Okay, and the rest I don't care about. So, oh, I know what I care about. Where's the midline? The x-axis is always the middle. Put it at 2. Put it at 2. Good? Okay. Tell me where to start. Move this up 2. 1, 2. Where are you going to start? 0, 2. That means if you let x or let theta be 0 degrees, you get 2 for an answer. If you let theta be pi over 2, what do you get for an answer? Pi over 2 gave me 3. What's pi over 2 going to give you on this one? 5. Just move up 2. It's 5. It's your maximum, right? Pi over 2 gives me 5. What does pi give you? 2. What does 3 pi over 2 give you? -1. What does 2 pi give you? 2. Okay. And it's just, that's it. That's it. Up, down, I guess. Okay. Yes, I get it. Say something. I hate to tell you this, but if you can't do this, I'm not sure how you're going to go to that. Okay? So number-wise, you're what? Ooh, I got some pretty good numbers. That's good because this is not supposed to be the hard part. The new part is coming. Okay? All right. Let me go here. You don't have this slide, right? Okay. What I need you to do is be patient with me. I need to teach you something about sine and cosine, and this is really going to help you if you can just listen to it, okay? All right. This is sine. Sine of theta. Sine of 0, 30, 45, 60, 90, 120. I'm hitting all the special angles, okay? If you did sine of 0, here's 0 degrees right here. Y is 0, R is 1. 0 over 1 is 0. Did you know that? Sine of 0 is 0. We just did it. Okay, what's sine of 30?
Square root of 3 over 2.
Say it again.
Square root of 3 over 2.
Okay, so here's 30.
I lied.
Opposite of 30 is 1. This is 2, so it's what? It's 1/2. Okay. Got it? Okay, now we can cruise, I think. Do you know the sign of 45? That would be this one. Square root of 2 over 2. Do you know the square root of 60? Square root of 3 over 2. Do you know the sign of 90? It's the y value over the radius, so it's 1 over 1 is 1. Hey, look at that. At 90, you reached your peak. That's your maximum. Now, what happens? Notice if you go 30 down from 90, you're at this. If you go 30 down from 90, or 30 up from 90, you're at this. What do you think the answer is? This right here. Is it negative or is it positive? Sign is positive in quadrant 1 and 2. So where's 120? 120 is actually right here. Do you guys see it as this? It's this triangle? Yeah, so it's the same answer. Square root of 3 over 2 is what it is. Okay. But I keep going, and guess what? Everything repeats. So just finish it, will you? What's 135 going to give you? And what's 150 going to give you? Half. What's 180 going to give you? 0. And now I didn't keep going because it just repeats. But all the other answers on the other side of 180 are all negative, right? Okay. Okay, here's the big kicker now. This is what I'm trying to get in your head. Let's graph those points. 0 goes in, 0 comes out. Do you guys remember what 30 was? It was 1 over 2, wasn't it? Half of the maximum is right there. So at 30 degrees, you get half. What do you get at 45? Square root of 2 over 2. You know what that is? It's 0.7. What do you get at 60? Square root of 3 over 2. What's that? 0.86. I'm not going to write 6. Which one of these seems very easy to graph? The half. This is the only point I want you guys to get out of these graphs. I could care less about that one, because those are hard for you to see. This is an easy one for you to see. Now, watch what happens. You hit your maximum right here at 90, you get 1. But as you go around the corner, what does this one give you? 120? It gives you the square root of 3 over 2. What does 135 give you? Square root of 2 over 2, 0.7. What does 150 give you? Oh, it gives me a half again. So where did the half show up?
180 around.
Say it again, 180 what?
A half the time around.
Okay.
No.
Okay, here's the deal. It showed up right here. Watch this. I gotta just show you and tell you so we can get going. This is a 0, agree? This is a 0, agree? Watch this. The half showed up when you moved. This is your peak. This is your max. If you look at your max from 90 to 0, that's 90 degrees. Your 1/2 showed up when you moved in 1/3 of the distance. If this is 90 degrees, 1/3 of it is what? What's 1/3 of 90? 30. Move in a 30 and go up, you get a half. Here's the other 0 right here. I moved in a 30, we'll go in a 30. This is 180. Move in 30, you're at what? What does 150 give you? A half. That's how quick you can do this. You don't have to sit there and think about it. Here's your 0. Let's go 130 this way. Let's go 30 this way. What's 30 this way? After 180, you get what? That would be 210. Now move down. How far? To about here. What would you get?
Negative 1/2.
Yeah, this is -1. You get -1/2. Yep. Okay. So where do you think the next one is? The next 0. They come down. It's come up. If this is 180, this is what? That's 360. So where's the other one? The other one would be move in 30, and then come down, hit it, and the other answer is what? 1/2. Anybody know this angle right here? 3 what?
30.
Yeah, it's 330. So what's really important to you is you can pick out the halves. So to me, here's a 0. Move in a 1/3. 30 degrees gives me a half. Here's a 0. Back up a 1/3. go forward a third, I'll get half here. Here I'll get negative 1/2. These are the big points. These are the ones you want. Otherwise, you're going to be guessing all the time. I'm not going to do cosine because you and I are going to do cosine right now. Here we go. Let's get started. Take one piece of graph paper, one side, and let's just do this, all right? Here's what you do.
Can you just use the graph paper?
Yeah, the graph paper you took, right?
This isn't a packet. We have some in our packet.
Oh, no. We want to be here. Because you have to graph it on the
But
X.
look, it looks the same.
It has the
Yeah.
X and forward.
Sorry. Go to your notes. All right, ready? Graph this equation on the Cartesian plane. And what I mean by Cartesian plane is x, y. But your x got replaced by what? Theta. So let's just graph. Do I expect you to put points in? No. I expect you just to be able to sketch this quick. If I were you, I'd probably get this one. Do 3 cosine of theta. Then right there, guys, that means what? Up 3. So you can just do 3 cosine of theta and then go up 3, and that's your real graph. Okay. All right, here we go. What's the period for cosine here? 2 pi. Divided by b, what's b? 1, so it's just 2 pi. Okay, so if it's 2 pi, I'll go 0, 1, 2, 3, 4. You know you're cutting it into 4 equal parts. 2 pi is when it ends. There you go. This would be pi. This would be 3 pi over 2. This would be pi over 2. Okay. All right. I don't want you to put numbers in. I just want you to sketch it. I'm sketching this right here. 3 cosine theta. What's the max and the min going to be? 3 up, 3 down, right? Whoops, I ran out of room, sorry. 3 up, 3 down. Okay, got it. I've got my period, I've got my maxes, mins. Where do I start for cosine? Is it 0? You put 0 and get 0? Or do you put 0 in and get the max? Cosine is opposite. It's the max. You start high. Naomi, stay with me. Please stay with me, guys. I got 1 to do with you. That's it. Okay? After my max comes my 0. After my 0 comes my minimum. Then my 0. Then my max. Right here. Okay. That's my graph. And I can just simply go like this. Okay, that's not the entire graph. That's just 3 cosine. This problem was not 3 cosine. This was 3 cosine what? Plus 3. Right here. So the plus 3 means go up another 3. So where does the max happen? 6. Right here. Where does this pi over 2 give you? What's the answer to pi over 2? 3. Pi over 2 would actually give you 3. What would pi give you? 0. You move this up 3. What would 3 pi over 2 give you? 3. What would 2 pi give you? 6. So the real graph looks like this. Okay? Good? Please don't look at the green one because we're not doing the green one. Okay? Matter of fact, I can get rid of it so you don't look. Okay? Okay, here we go. Here's what you do. You have been converting points for the last 3 days. We're going to convert points. Here's all you have to do is this. Grab a point off of this one and then convert it to our theta. Well, this point right here, I'm going to write this down, is what? 0.6. 0 degrees 6 for the y. What's this one?
3 pi over 2.
Oh, it's
Or pi over
angle first over pi over 2. Then what? Up 3. What's this one?
Pi 0.
Over pi up 0. This is the xy coordinate system. This far, okay? What's this point right here? 3 pi over 2, then what? 3. This one, comma, up 6. Good? Were those hard? Now, here comes the hardest part for you. Ready? I need you to tell me where the new midline is. Remember the old x-axis? Didn't it go up 3? So where's the midline? Right here. Isn't this the midline? Okay, that's like the new x-axis. So if that's the new x-axis, where are the zeros? Pi over 2 and 3. Yep, you got it. That's a 0. This is a what? Another 0. This is important to you. Okay, I need you to understand. Go find your zeros, and then from there you can pick out some good points. Did you listen? Ready? How far is it from the 0 to the max? How far is this? Right here. Yeah, it's 90 degrees. 90. Where did I say the halfway mark would be? From the 0, go over a third, go up, hit it, come across. Do you know that if that's 90, how far did I travel backwards? 30, because that's a third of 90. So go 30 backwards, where are you at? 60, you're at 60 degrees. So guess what that point is? Right here. Pi over 3, right? Comma, 4.5. You're up, you're halfway between the midline and the peak. You're at 4.5. That's where everybody's getting confused today. If you just think about it, I went 30 backwards, because that's a third of 90. Go 30 forward, come down, hit this thing, come across. Oh, look, it's halfway. But if I go 30 past 90, where am I at? Where? 120. 30 past 90 would be 120. So this point is 120 degrees, or 2/3 pi, right? So at 2/3 pi, I get, what's the y value? 1.5. 1.5. That's an easy one. I don't care about this one. I keep going around the corner. I get to my next 0, and there it is. Now from there, from every 0, you just go backwards a third of the distance between the min or the max. Here's the min. Here's the min. From there to there's how far? That's 90 degrees. What's a third of 90? 30. So go back 30, and guess what? You're at what? That's 270. 240. Okay, what's 240? 240 would be 4/3 pi. So this point right here is 4/3 pi, comma what? 1.5, yeah. If it bothers you that I'm using radians, could you just say angles? Could you say 240 degrees, 1.5? Could you say 120, 1.5? It's the same thing. If that makes you feel better, do it. Okay, now from the 0, go 1/3 of the distance. That's from here now. That's still 90. Go up, hit it, right there. And guess what the answer is? 4.5. But what's that angle down here? Yeah. But in degrees, it's 300 degrees. 30 degrees past 270 is 300. And 300 is what? What'd you call it? 5/3 pi. So that point is 5/3 pi, comma, 4.5, right? Good. Now, did you have to write all that out? No. I'll show you what. I had to write it out so you could see it, but you don't really have to write it out. You just need to do this. We're going to graph those same points, except where? Down here. Now, give me the very first point we got. 0 degrees what? 0 degrees, 6. Well, that's your x, comma, y point. You can't graph this on this. So you got to go over here now and say, oh, I want this to be r comma theta. And here's the weirdest part about this whole thing is right here. You see your degree? 0
That'd be
degrees?
the other way around. Shouldn't it be 6 here?
No. When you go back up there, remember this?
But it's R.
No, I know, but remember the x-axis? The x-axis turned into what? We turned it into your theta. We turned it into theta. So the x's up here were theta, and the y's were your height. So that's the weird part. So here's the deal. When you come down here, 0, 6 gets reversed. The angle has to go second, 0 degrees, comma, and then what's the radius? It's actually the y value, 6. So it flips, yeah, it flips. So how do you graph 6 comma 0 degrees? 6 over, rotate 0. Oh, guess what? I didn't move. And this is why you don't have to do all those points up there. Every time you get a point, reverse it in your head. What was the next point? 2/3. Well, you jumped a lot of points. Wasn't it pi over 3 comma 4.5? Okay, the next point was, I believe, pi over 2 comma 3. Okay, and if you just keep reversing them, you're going to get polar points. 4.5 comma pi over 3. 3 comma pi over 2. Okay. Now, once you start graphing these, it starts to form circles. Here we go. Where is 4.5 comma 60? Well, over 4.5. Up what? Not up, I'm sorry. Rotate what? 60. I can't see my graph paper, guys, but I think that would be about right there. Good? Okay, so I'm going to erase the rotation and just try to get you to understand this. It is not a jagged graph. It's nice and circular. So it's very curved. I can't make a graph yet. Let's keep graphing. What's this point look like? 3 comma pi over 2? Out 3. Then what? 90 degrees. Yep. Out 3. 90 right here. Here's what I can tell you. It is a very smooth curve. It's always smooth and it's always rounded. And it always heads towards the pole. Okay, what was the next point after 90? I believe it was 2/3 pi. And then it was pi. What was 2/3 pi? Wasn't it 1.5?
Yeah.
What was pi? Zero. Are you guys are looking, right? Look at your graph. So now I'll reverse these. 1.5 radius, rotated 2/3 pi. Okay, and then I'll do what? 0 for my radius, rotated pi. Where's 1.5 2/3 pi? Over at 1.5. Rotated 120 degrees. Okay. Starting to head towards the pole, isn't it? The pole is the origin. Okay, what's this? How do you graph 0 comma pi? Don't go right, don't go left, just rotate it pi. Well, if you rotate this pencil pi, I mean, you're right there. You just hit the what? You just hit the pole. It's not the origin in polar. You hit the pole. Are you going to go through the pole and make a loop and come out, or are you going to bounce off the pole? Hit and run, says John. Think you're bouncing? Okay, let's try it. What comes after pi up there? I believe we got 4/3 pi, didn't we? 4/3 pi was 1.5. So, reverse it. 1.5, comma, 4/3 pi. Well, that would be rotates. 4/3 pi is 240 degrees. So, Skylar, I think you're right. It bounced. Didn't you say it bounced? Somebody said it. It bounced. It can almost tell me, can you see the symmetrical part of this?
Yeah.
Okay, you know this is 0 up 3. You think it's going to be 0 down 3? I mean, what was the next point? On that rectangular one. Wasn't the next point 3/2 comma pi? What? Wasn't it 3? I think it was, wasn't it? So if I reverse those, I get 3 comma 3/2 pi. Which would be 3 rotated 3/2 pi. I'm right here. Okay, now I'm pretty sure I'm right, guys. I can probably mirror it across. There's only one point to mirror. It's this one. Mirror that one across and you've got it. By the way, this one was 4.5, 60. So I could go 4.5, negative 60, right? So that would be, oh boy, somewhere here. So it goes like this, 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 and back to here. What is it?
A shade.
What kind of shape?
Peach.
A peach.
It's a heart.
It's a heart. It's a cardioid. They call it cardioid. Okay. Anyways, that's it. That's it. Now you need to graph the coordinate system, XY system, steal the points. Do you have to write them out? No. You can reverse them in your head. I would just keep reversing them as I go. The more points you get, the better the graph looks. Somebody said, can I just do that point, that point, that point, and that point? And the answer is no. Those are your 5 key points. That's not good enough. You won't know what to do. You won't know if you're going to go here, here, here. You'll think it's a triangle. It won't make sense to you. You need more points is what I'm trying to say. I was trying to give you hints on when are you going to be halfway up the graph. It's always wherever the 0 is, move a third in, move a third in. Notice I say third in, third in. Usually it's been 30. But what if the period starts to change? Then it might be only 15 degrees in and 15 degrees. But you know what? All you're doing is estimating where that point is. You just got to get a feel of what angle you're talking about. I'm done.
Okay, I have a question.
Oh, by the way, number 1 is this problem, except what?
Choose instead of 35.
Yeah, 3's are gone, it's down to 10.
So with this point, that's so stupid. From like 30 and so then be 60, which is 5 over 3. It is, that's how it works. So
Well,
then,
yeah, when I say it's so bad, it's always, yeah, that would have been
yeah. And then, so then I put this one 5 over 2, right? 2, and then I go this way.
I'm pretty happy because the lecture was going to live today.
Yeah, and now you're going to get this.
Yeah, also 2 and then do I have to put in my second?
No, I already told you that I'm going to stay.
Well, you wanted
I said to you, you respond to me. You respond to me and Eddie.
Yeah.
Sorry. Don't call me out on it. I know where you're going. Yes. Here. I don't know about you.
This is
You're sketchy.
I put up 2.
Yes. It's kind of like the others.
This is your
Almost on 15. Day 1 of days and 7.
Oh, I know I am. I'm gonna go behind.
But does that really matter? I just drew it fast.
Yeah, I know.
There's one of these next week, so do I have that? Why do you so much?
I've seen worse. Try being gone for 2 days.
0 degrees or just 0?
That should be angry. That should be. You went up to
So then this one, I go 30 this way. So it'd be
It's just a halfway, you don't have to go across, what's halfway between two?
well, it's one.
Yeah.
But then
That
it's
is, 3 pi over 2 is
240.
2.
Everything.
Yeah, do you use wolf? I use wolf.
And then I have 30 this way.
Yeah.
So it's 3 again. But it's
See the reason, you can be using anything like,
300.
Almost basically.
this is why you're.
Yeah, but it's highly specialized for math. So like you can,
Oh.
Here's your midline,
you can understand what you're asking to do, which when you start working with higher level math, getting the program to understand what you want it to do is the hardest.
That's your,
And Wolfram Alpha's really good at it.
so you're,
You'll
yours
use
is
it
going
all
this way,
the time.
and it's supposed to be
Check
you're
your
down.
I also have
You got yours is a little off, which is
an actual engineer.
It's not?
Oh, yeah, might be a bit.
You have to do this one now too.
Well, I
Oh,
would
you
say
said
right
that
now,
was
it's, 2 pi gives me 4.
Trust me.
Give me one of
Yeah, it's constant keeping up with it.
And now,
Why do you
with
give
all
me
those
so
points,
many?
you just
Because
reverse
I
them.
take
You have to.
3 of these graphs.
Yeah.
8. I didn't.
The first point is,
So
you're
many.
doing 4. You're doing 4.
Why'd you give me so many?
He didn't change.
1, 2, 3. Worksheet.
Made a dog.
It's a fish.
Oh, fish.
It's definitely a fish. It doesn't look like a dog.
I thought it was, I mean, this is the look I should have, right there. Upside down, it has, I thought that was it, I don't know, because of the nose.
Well, you see,
I see what you're doing.
on the
I got
branches, you have to order.
You okay?
Yeah.
If I come over there, what?
No, not you. I'm him. It just made no sense to me, so I'm going to have to come in during third hour probably on Monday.
All of the
Cause I have
things.
a free hour then.
We do it every,
We used to kitchen if I so choose.
I
I
get you.
can eat it for free if I so choose.
Oh, I should have just done that.
Oh. Yeah, I think I'm doing.
Think they're gonna stop